Welcome back to God Maths. In today's lesson, we will discuss the basic concepts of probability. Before we get started, don't forget to subscribe to this channel for more video lessons. In the field of business and economics, so many future decisions are taken. These decisions always come with some level of risk and uncertainties. Probability enables us to measure these risks and effectively apply them to the benefit of the business or the economy. Let's look at some basic terms that we will come across in the study of probability. Now, the observation of any physical occurrence is called the experiment. So, any physical occurrence we observe is called an experiment. Then, that physical occurrence or that observation come with some possible outcomes. The set of all those possible outcomes is what we call the sample space. Then the real outcome of an experiment, which is also a subset of the sample space, is what we call an event. The exact outcome of an experiment, which forms part of the set of all possible outcomes, is what we call an event. So we will take some practical examples under probability. Let's take an experiment such as the throw of a die. In throwing a die, even though we don't know the exact number that will show up, we are sure that that number will come from this set. These are the numbers that we have on a die. So before throwing a die, we know this is the set of possible outcomes. And that set of possible outcomes, like defined in the terms, is called sample space. Let's represent the sample space by the universal set U. So U is equal to 1, 2, 3, 4, 5, 6. Now within this sample space, if we want to find the probability that an even number will show up, the probability that an even number will show up, then we go to our sample space and then find the even numbers within that sample space, because that is the real outcome we want. Let's represent that set by E, and that is going to be 2, 4, 6. These are the even numbers within the sample space, and this subset of the sample space is called the event. With the theoretical or the classical approach to measurement of probability, we say that probability that an event will occur, which is represented by P of E, is always equal to the number of sets in the event divided by the number of sets in the sample space, which we represent by U. This is the classical approach to the measurement of probability. So, for an example, if we have A fair die is thrown once. Find the probability of obtaining an odd number. Then we know the classical approach to measuring probability, which states that probability of an event is equal to the number of elements in the event divided by the number of elements in the sample space, where the number of the event itself is the set of the real outcome, so an odd number. But before we get the event, we must get the sample space, U, which is equal to the set of all possible outcomes. And so the sample space for the die is 1, 2, 3, 4, 5, 6. These are the possible outcomes you can get from the throw of a die. Then, dealing with an odd number from this sample space, we will have 1, 3, 5. Then, the number of elements in the event, which is what we are more interested in, is 1, 2, 3. And the number of elements in the sample space is 1, 2, 3, 4, 5, 6. Therefore, our probability of the event will be number of elements in the event is 3, that in the sample space is 6. So our probability will be 1 over 2. Note that probability should always be written as a fraction in its lowest term. Let's take other practical examples under this. A fair die is thrown once. Find the probability of obtaining a 4, a multiple of 3, an even number. Note that these real outcomes of the experiment are what we call the events. And then the events are always obtained from the sample space. So in the first question, we need the sample space first. We represent that by U, and it is the set of all possible outcomes from the throw of a die, which are 1, 2, 3, 4, 5, 6. And then the number of elements in this set, which we will need to find our probability, is 6 when we count the elements. So in the first question, A, we want to get the probability of obtaining a 4. So an event is a 4. Our event here is a 4. So the event will be equal to, we look for the 4s in the sample space, and there is only one of that. So the number of elements in this event will be 1, a single element. And our probability of that event occurring, which is the number of elements in the event over number of elements in the sample space, will be 1 over 6. A fraction in its lowest form. B, our event is a multiple of 3. So we go through the sample space and generate the multiples of 3. And we have 3, 6. Then the number of elements in this event is 2. And our probability of this event occurring, the number of elements in the event over that in the sample space, that gives us 2 over 6. In the smallest form, it is 1 over 3. C is an even number. So our event here is, we have the even numbers from the sample space as 2, 4, 6. And the number of elements in this event is 3. 1, 2, 3. So our probability, number of elements in the event is 3. That in the sample space is 6. And we will have 1 over 2 as our probability. Let's go to the second question. A coin is tossed. What is the probability of obtaining or getting a head, a tail? In this experiment, our sample space, U, will be equal to head and tail. The coin has two faces. We are calling one face the head, the other face is the tail. And so the number of elements in this sample space is 2. Then for the events, our first event is obtaining a head. So let's look for the heads here. We have only one of that. And the number of elements in this event is 1. So our probability will be equal to number of elements in the event divided by number of elements in the sample space. Then we have our second one. The event is obtaining a tail. And then the number of elements in this event is again 1. So our probability will be equal to 1/2. Now you notice that in this experiment, the probability of getting the head is 1/2, which is the same as the probability of getting a tail. In the event where, or in a situation where the probability for obtaining each event is the same, then we will say that the events are equally likely. So equally likely events have the same probability of occurring. Then now we are taking an example for the throw of a die, an example for the toss of a coin. What if we have a coin and a die and we perform the experiment at the same time? Let's look at what happens. So another example. So in this case, we are performing two experiments at the same time, and therefore we will have two outcomes at a time. Let's get the sample space for this. We already know that the sample space for the toss of a coin is either a head or a tail, and the sample space for the toss of a die is 1, 2, 3, 4, 5, 6. Let's put these two together since we are doing them at the same time. So we will have 1 and a head, we will have 1 and a tail. So this becomes our sample space, the set of all possible outcomes. And you know there are two outcomes at a time. So this is our sample space. And the number of elements in our sample space is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we will say that n of u, which is the number of elements in our sample space, is 12. Let's go to the event. The event is obtaining a head and an even number. So let's go through the heads. Which one are having an even number attached? This is odd number and head. This is even number and head, even number and head, even number and head. So our event will be, we have 2 head, 4 head, 6 heads. And the number of elements in this event is 1, 2, 3. 3. So our probability of this event occurring, which is the number of elements in the event over number of elements in the sample space, will be 3 out of 12. We must write in the lowest form, and that will give us 1 over 4. We will take further examples under this. 46 out of 100 people in a certain town are left-handed. Find the probability of randomly selecting a left-handed person from the town. We have already discussed sample space and events, and sample space is a collection of all possible outcomes. In this question, we have a total of 100 people in a town, so that becomes our sample space. Then from that 100 people, 46 are left-handed, so this becomes our event. We have already said that the event is a subset drawn from the sample space. And so for this question, our sample space, the number of elements in our sample space is 100 people. And the number of elements in the event is the 46 selected from the 100 people. Then our probability of that event occurring, which is the number of elements in the event over number of elements in the sample space. We represented that by U, and that will give us 46 over 100. In the simplest form, we will have 23 over 50. Then our second question. Last semester, a certain professor gave 13 A's out of 285 grades. So the total number of grades is 285, and that is our sample space. And then the number of A's he awarded out of this is 13. This becomes our event. The number of elements in the event is 13. So our probability, number of elements in the event over number of elements in the sample space. Then for the third question, last year it rained on 75 days. Find the probability of rain on a day selected at random. How do we get the sample space from this? We know that the total number of days in a year is 365. So our sample space is 365, from which it rained on 75 days. So the number of elements in the event is 75. Then our probability will be equal to number of elements in the event, number of elements in the sample space. We break this down to the simplest form, and that gives us our probability. Further, you must know that every probability must obey some conditions. So we are going to look at the conditions that every probability must obey. Every probability value must satisfy the following conditions. 1. The probability of an event always ranges from 0 to 1. When the probability is equal to 0, then we say that the event is impossible. So 0 probability is impossibility. When the event is 1, we will say that the event is certain. So when probability is equal to 1, we call it certainty. Now let's take a small sample space to justify this. Let's take U equal to 1, 2, 3, 4. And then we want to find the probability of an event occurring. The number of elements in this sample space is 4. When we take an event E equal to 1 and 2, our probability will be equal to the number of elements here is 2, divided by the sample space is 1 over 2. And note that the highest event we can get is all of this. And that event will be equal to the number of elements in that event will also be equal to 4. So probability will be 4 over 4. That will give us 1. And the smallest event we can get is a null set. We said the event is a subset of this. And the null or empty set is a subset of every set. So the number of elements in an empty set is 0. And that probability will be equal to 0 over 6, which will give us 0. So probability value must always range from 0 to 1. The smallest is 0 for the empty set, and the highest is 1 for the entire set. Let's go to the second condition. That is called the complement. And it states that the probability that an event will occur plus the probability that that event will not occur, which is called the complement, is equal to 1. So this is called complement. And we can justify that as follows. If we have a sample space U equal to 1, 2, 3, 4, 5, assuming our event here is an even number, then the number of elements in the sample space is 5. The number of elements in the event itself is an even number, which is 2, 4. So the number of elements here will be 2. Then our probability will be number of elements in the event, 2 over 5. Now the complement of this is when we take out the even numbers, what are the elements that are left in the set? So the complement of this event, which we will write as this, will be equal to the elements left are 1, 3, 5, and the number of elements here is equal to 3. So our probability will be equal to 3 over 5. When we add these two events, the probability that the event will occur plus the probability of the complement, that is the event will not occur, will give us 2 over 5 plus 3 over 5. This is equal to 1. And it is always true that the probability that an event will occur plus the probability that the event will not occur is always equal to 1. In our next video lesson, we will look at mutually exclusive events, independent events, and conditional probability. See you in our next lesson.